Permutations. Given an array of nums of distinct integer, written all possible permutation, you can return the answer in any order. Now, what is permutation? Basically, permutation is all possible. You have to find all possible or all different ways to arrange these elements. For example, they have given this 1 2 3, right? So they have given us 1 2 3. How many possible ways are there to find that you can arrange this particular number? So this is 1 2 3. So you can, first combination is 1 2 3. Next combination is 1 3 2. Then next combination is 2 1 3, 3 1 2, 3 2 1, 231, right? So how many combinations are there? One, two, three, four, five, six. Six combinations are there. So what we did in this combination is we are just rearranging the numbers and finding that particular combination, or we are finding the permutation. Sorry, not a combination, it's a permutation. We are finding the permutation by just rearranging those particular numbers. And the catch over here is we cannot have the duplicate numbers in our permutation. For example, we cannot have numbers like 331. This is not a permutation number. This you cannot do it because we have to maintain a distinct unique numbers. Next catch is you cannot have the permutation like 3312. So obviously this is a duplicate number, but also you cannot increase the length of that particular number. It should be always, if the array, if the nums array which they have given is length of 3, then all your permutation should be always of that same length. Let's take another example. Another example which we have is 0 comma 1. So what is the permutation for this particular number? Obviously you have this permutation and you have 1 comma 0, this permutation. You cannot have 0 comma 0, or you cannot have 0 1 1 0 like this, because you cannot increase the length and you cannot have the duplicate permutations for that particular number. So first foremost is it should be just rearranging of the numbers in all possible ways. That is the permutation. And there are two base cases. What are those base cases? It should not go ahead of the length, and it should not have a duplicate number. These are the two base conditions. So we understood what we need to do it. Now, another thing which I wanted to make you understand is, let's take this is the character array, and if you see how many permutation you can make of this particular number, let's try to understand that. So this first character can have the permutations of three, in three ways, because it is at the third position. Then this particular character is at the second position. It will have two, as two permutations it can make it with that particular letter. And the last you can make is the, you have a choice of one permutation you can make it. So in all, 3 into 2, that is 6 ways you can have the permutation of that particular character array. Now next thing which I wanted to let you know is the permutation of one particular char array. Let's see how to do it. Okay, how exactly we can solve this permutation. First thing first, we are going to take the first letter, that is A, and do the permutation of that particular letter. That is, we are going to have A as a, we are going to take first as A, next we are going to take it as B, and third we are taking as C. So if you have observed, what I did right now is I took the letter A and then I'm going to make a permutation as, let's take different color. I'll make a permutation as um, A, B, C. Then I'm going back again and taking B as my first and doing a permutation with A and C, right? Again, I'm going back and doing a permutation of C, B, A. If you observe, the one format which I am doing is I'm going back. I'm checking the going back to that length, taking that one letter and doing the permutation. Length remains the same. Again, I'm going back, taking the next letter and doing the permutation. Again, the length remains same. So this is nothing but I'm trying to do the backtracking over here. Now let's take, so here we took A, right? Now we have to take here B, or we have to take here C. Again, here we have taken already B, right? So we have to take here A and here C. Again, here we have to take letter B or letter A. So if you observe, again you will have the sixth permutation of that particular number. What exactly we are doing? We are again going back, taking another letter. We are again going back, taking another letter. Again going back, taking another letter. That is nothing but we are using the backtracking method over here. Let's take another example to make you understand more better. Suppose this is the case, right? We have B, O, A, T. This is our, we have to make different permutations of this particular character, of this particular characters. So what we are going to do, first we are taking B, again going back, then take O, again going back, then take A, again going back, and then take T. Now we are maintaining whatever the character which we are taking, we are putting it in one array, and then we are putting the remaining ones in different one, that is O, A, T. Next thing, same thing you have to do it over here also, like O comes in one array, then you have B, A, T. Next, again here we have to do the same thing, A in one, and the pending ones you have to put in a different format so that you understand what you have used and what are the pending ones. So we have used A, so the next is BOT. Next here is T you have used, so next is BOA. Now I will just show you for this particular characters the ahead, others you can always do it. So here, right here you have taken B, right? So now you will take O. So in this we will have BO as one format because we took O, and in another you will have A and T. Next, you can take A, or next you can take T, because these are the three characters, right? O, A, T. So you have to take one by one. O, then you take A, then you take T. So what exactly I'm doing is I am just trying to take next numbers, next letters, next element, and then I am doing a backtrack, again going back, taking next number, again going back, taking the next letter. So this way I'm trying to make the permutation. So here, when this is A, right? So here the permutation will be BO, and the pending is here, sorry, BA. We have taken A, right? And OT. Next over here it will be, for this we will have the permutation of BT, and the pending ones are O, A. These are the pending ones. So this way you can make the permutation by just doing a backtracking. Always go back and take the next whatever the next element is. But the catch over here is the base case conditions are very important to do this particular permutation. So basically they are asking us to do the permutations in this particular fashion, and it will have a backtracking method which we can use it. And for the permutations which we are doing is n factorial. So these are the n factorial permutations, and we are going to iterate this n times. We are going to iterate this n times. So O of n factorial into n will be the time complexity. But obviously we have to do this permutation with the help of backtracking, because we are always going back, taking the next letter, always going back, taking the next letter. This is the format of backtracking. We have to iterate that particular array by going back and taking the next element, and two base conditions which we need to write it. Let's start coding public list of integer uh, permutation, and here I will write, I'll provide nums array over here, and let's define the result list. Result list will be in list of integer, because we have to put our answer into this result list basically. So I'm going to create that, and then we have we need a backtracking function. We need a backtracking function which I will be writing over here now. So backtrack. In backtracking function, I'm going to provide result list. Then I'm going to provide new array list. Then I'm going to why I'm doing this new array list. So usually if you saw my diagram, we have to start somewhere, right? We have to start somewhere. This is a result list where we are going to give our answer. But to start adding the numbers and to form the permutation, we need an extra array list so that we can start doing our permutations. That's the reason we have taken the new array list, and we are going to return over here the result list. Now let's see what is there in the backtracking method. Let's see that. So let's write this public backtrack list of integer, um, that is the result list, and our new array list is, let's say, temp list. I'll take this as temp list, and then my nums array. This is the nums array which the input is there. We have an input, right? So we already have that input, so we are just using that as our nums array. Now first foremost, what we have to check is the length. If the length is same, then we are just going to return it. We are not going to do anything. That's our base case condition. So if temp list dot size is equal to result list dot length, result list dot size, then just return it. We don't have to do anything. Next, what we have to do is we have to iterate the nums array. We have to iterate the nums array. So let's say we are iterating the nums array, and what is the condition we are checking over here? That if our temp list dot contains that particular number, then we are just going to continue it. We are not going to do anything again. These are the two base conditions which we have to maintain it. Now we start our real backtracking. What is the real backtracking which we are doing? What are we containing? So first we are taking the first number, right? We are adding the first number over here. Then we are going back. If you see, we are going back, and uh, as I explained you, we go back, take the again number. So this is what I'm writing. We are doing a backtracking over here. And in the backtracking, again, once we take another next number, we are going to next what we have to do. We have to remove we have to remove the size. So basically what I'm trying to say over here, we have to maintain the size, right? So if you see in my backtracking, see here, I have taken B, right? I go back, I take next O, and I'm putting this O, but I am removing this B. I'm removing this B. Why I'm removing? Because I want to maintain the size. I want to maintain the size. That's the reason I have to remove whatever the length was. Earlier length, I have to just remove it so that I can you take the next number and pending numbers I can add it. Pending elements I can add it. That's the reason I have to remove. That means I can maintain the length of that particular array. So backtrack and maintain the length of the array. Backtrack, take next element and maintain the length of the array. That is what we are right now doing it. So last step is we have to remove size -1. And this is all what we have to write for this permutation. Exactly, we are just maintaining the size, and if it contains the same number, we are not going to do anything. We are just going to continue it. And these are the steps which I told you, explain you. Like, you have to take the next number, do a backtrack, take a number, and we have to for maintaining the size of that particular list. I'm removing it one element so that I can retain the size of that particular temp list. And this temp list is then added into the result list. So we can write here instead of return here, of course, we have to return it, but we have to mention that once we retain the size, template size, we retain it same as that of result size. Once we do this same, once we get the same size of both the array, then what we have to do is, I forgot to mention this, result list dot add temp list. This we have to add it, right? I mean, once, so the thing over here is once we get the same size, okay, once we get temp list dot size and is same as that of result size, simply we have to add this temp list in my result list and return that result list. That is what I missed. I'm sorry for that. And this is what is the code. These are the two base conditions, and this is the three which we are performing our backtracking. Thank you for watching.